Alright, here's another update video for you folks, and I promise it's going to be rather boring. Here's the straight shot turbine that I've been working on. I've got it up on a tower. Those blades that are on it, I've got 6 of the PVC, the steel banded PVC blades that I've had for years and years. In fact, if you look at some of my older archived videos, you'll see all the different treadmill motor videos, same blade set for years and years. This one is a little over 60 inches in diameter. I'd have to check exactly, but that's in diameter. Each blade is about 28 inches long, and again, there's 6 of them. So I'm going to show you a few clips here, and then kind of explain my way through them. But one thing that I think is worth mentioning here is wind location. Part of the problem is where I have this thing located, the wind has to climb a little bit of a hill, houses and trees along the way, and as soon as it drops off the hill, basically it comes up over the other side, and it has to come downhill to this location with trees and houses the whole way along. There's no substitute for a good wind location, and this isn't one. Although we do get good winds here, you can see it hunting around a little bit. That's because it never will see a straight line wind, and I still have yet to bring it out into an area that is going to get a clean wind. So that's on the program at some point. But in the meanwhile, it has been up here for a few weeks, and I have it on the Schedule 80 tower, Schedule 40 tower. And I think in a previous video I said 2.5 inch. It's not. It's a 2-inch Schedule 40 pipe. The axis of the turbine is 15 foot off the ground, and I did get the in-speed wind meter, as you can see right off to the side there. It's hard to tell because I've got a bit of a telephoto lens, but it's not very far. The blades miss it by about 20 inches, so it should be a pretty accurate reflection of at least the wind that's moving through the area, although I think with turbulent wind, the wind hitting the top of the blades might not be the same as the bottom. So anyway, all that being said, here's some of the results. Now this, you're going to have to take my word for it, is 20 miles per hour with gusts that broke over 30 on the in-speed. So I think the top speed was 34 miles per hour wind speed, and there you see I'm sped up four times here on Windows Movie Maker. So sorry for the little motion distortion there, but I have it hooked up to a power inverter, and it's running down about 85 feet of the cheapest extension cord you could find at Walmart in the early 90s. So thin gauge stuff running 85 feet of length, and so there's definitely some losses, I would assume, from that. It's the cheap thin extension cord, 3-phase. I'm going to upgrade all this in time, but I'm kind of a use what you got kind of guy, and then eventually I have to spring for things like this kilowatt meter and the the inverter up there. But at one point here, I think toward the end, it hits 232 watts, which I'm pretty happy with, considering this is a backyard residential dirty wind turbine. So anyway, we'll watch that out for a little bit, and again, some of the wire gauge on all of it's just pretty thin, so I don't know how much of a difference that's really going to make. If there's a little impedance in the line or something like that, but the turbine itself, main thing is it held up pretty well. And this again is the PVC, the steel banded PVC blades, 6 of them, doing this. And then in the next video clips coming up here, you'll see there's the Falcon blades, which I had purchased for it. Unfortunately, they weren't on for this, and it wasn't like I was going to go out there and change them when we got this little storm burst here. There was a storm about to roll in, and I got this footage. So anyway, there it is. I broke over 200 a little bit there, but I was kind of excited to see it. Again, sorry, so boring on the footage here, but here comes the Falcon blades. As I watch the Movie Maker thing here. Okay, and there they are. The thing that I like about these is they're a little heavier. The whole blade set, I think, is 10 pounds, and I should have weighed the others, but I'm certain that they're a little bit lighter. So the other ones will speed up quicker, where these will kind of coast out. And the Falcons definitely, and they're Falcon Mach 4s by Missouri Wind and Solar. These were, they have a tendency to just coast once they get up to speed there, and so I imagine if I adjust my cut-in speed, I can get a little instantaneous power out of them. But you can see, in 6-7 miles per hour, I start to hit charging voltage, which is pretty nice. But again, it'll still hunt around. And in my situation, being suburban wind, where, right there, it's coming from due south, maybe southeast, which is a really bad way for it to come. Right around there is perfect. That's west, and southwest is okay, but there's still a big willow tree just right upwind. So with a heavier blade set, I'm not sure that that's best. That might be better for a more of an exposed area. If you're going to be in a residential area where the wind's whipping through, which isn't probably a good place for a turbine anyway, you want something that's going to come up to speed very quickly, I would guess. And these may not be ideal for my area, but they are great in that they do they do pick up, start charging, trickling in something in very low winds, which is good to see. So anyway, a little bit more of this boring video, but you can kind of see let me just mention two other things. One other thing that's great about them is they're very well balanced. I always weigh all my blades. These things were right on, and I could balance a martini on the back of that tail. That thing is balanced as can be, and I've made the hub to accept a 17 millimeter, all those eBay blades. So I may be trying some others, depending on what I can find on there. Obviously, there's lots of different styles and whatnot, but and money doesn't grow on trees. But I might try another set of blades on here that will fit a 17 millimeter hub. Now this is an interesting video in the sense that you can see some higher winds. This is Falcon blades again, Falcon Mach 4s, and again it drops down. But then I unhook the wind turbine from the battery. This is going straight. Both of those, with these multimeters and the in-speed, are going directly into a 12 volt deep cycle battery without a charge controller. So you get an idea of just having load on there. That just you're going to watch the amps on the right and its voltage on the left. I will unhook the wind turbine from the battery right there, and you'll just watch on the left the volts rise to open volts. I just let the turbine go. And this is with the Falcon blades, and with very low wind, it'll run itself right up. There you see 5 miles per hour, 20 volts, 21 volts, 7 miles per hour. It starts rising. So it does, open volts are open volts, but 10 miles per hour, you see that? I'm up in the 30s. The axial flux is quite a break. It almost stalls them out. So there's a little something to think about. Then I get a little instantaneous. I hook it back up, get a little spark, and it drops it back down. Battery voltage is at 14.1, and I'm at an amp and a half or whatever that wind speed was there. But you get the idea. Kind of chatty Cathy here, but just giving you a visual of this different turbine design. Muddy and I have been working on the Mini, Muddy's Mighty Mini, which had a furling mechanism, and then I had some extra basically turbine parts, and I made 3 of these straight shots. I'm calling them, and you're going to see another one show up on another YouTube user's site in a little bit. I just sent another one out to a good guy out there, and I'll tell you about that one later, and you're going to see it. So anyway, quick update. Thanks for your patience with me. As usual, I take a long time between uploads, but thanks again, and until next time.